So for this question 13, they said it's a cubic. So this question, they didn't give us our polynomial. What is that? They just said this polynomial is a cubic, means this polynomial will be x power to 3. Then they give us two remainder. One is remainder 3 and one is remainder 1 divided by x equals to 1. This is x equals to 2 respectively. So the first question, they say qx will be the linear factor. So they just label qx. Here is another linear factor. Such that our polynomial is cubic, right? So our polynomial is cubic, right? So its factor should be have 3 lah. So 1 factor, 2 factor, 3 factor, and the back here will be the remainder part, because our writing of polynomial will be in this form: px, what's your divisor, and then what's your quotient, plus at the back here will be remainder. So where alpha, beta are constant, find the remainder when the px is the polynomial is divided by x minus 1, x minus 2. So from here, so they say ask us to find the remainder, means ask us to find the original alpha. What is alpha? What is beta here? So our polynomial doesn't necessarily to be fully expand like the question previously. Doesn't need to expand like this. It also can be factor form. So we will use the factor form that given us here. So they said they want to divide by this x minus 1 and divide by x minus 2, and then the remainder is here. So we write out our remainder theorem when x equals to 1, so p1 equals to 3. Because when you divide it by x minus 1, remainder is 3. So another information, when x equals to 2, p2, the remainder is 1. Then we start to substitute our 1 into our polynomial in the, not the expanded form, in the factor forms here. Okay, so when I substitute 1 into the polynomial, you'll notice that here 1 minus 1 is 0. So leaving alpha plus beta. So another information, when I want to substitute 2 into the polynomial, you can notice that this don't have problem. When I substitute 2 here, this part will be 0. Just 0 times everything becomes 0. So meaning our polynomial is here 2 alpha plus beta. So find out what is our alpha beta first. So that will be our remainder when your polynomial is divided by x minus 1, x minus 2. We can do equation 1. We can see similar beta here. So 2 minus 1 here, we get 1 alpha, where beta is minus of is eliminate, and then 1 minus 3 will equals to negative 2. So we get alpha. Substitute this alpha into 1. So beta will equals to 5. So therefore you can see our polynomial now is incomplete. Polynomial is equals to our factor, or we can call it our divisor here. Then qx, our alpha is negative 2x plus beta. Beta is 5. So they said find the remainder of this px when it divided. So this is our divisor lah. Either you want to divide just now divide 1 by 1. So this is our divisor. So this part is our divisor. What is our remainder? You can see in the form. This is our polynomial. This part is our divisor, because it said polynomial divide by this factor. So this part will be our quotient, or means this part will be our remainder. So therefore our remainder here is equals to negative 2x plus 5. So from here, our reminder theorem for the first and second both get one answer, reminder theorem for these two. And then solve the simultaneous to get alpha beta. So finally we state out our reminder here. So this will be another form of polynomial which is writing not in expanded or not in x cubed, something x cubed, something x squared, and then x b c like that. So B, use the value alpha beta, so use this alpha beta, and then determine this Qx. So this Qx is its quotient, and the Qx is say another linear factor, because our polynomial is cubic, right? So means our factor here, our divisor here must be in power of 3. So since this x times x already power of 2, so this quotient will be another factor, is a linear factor. So this one will become ax plus b. So if the coefficient of x cubed for the polynomial is 1, p3 is 7, so we need to solve for x when the px is equal to 7 minus 3x. So originally we have to come up what is our quotient here, what is our linear factor here first, then only we can get a complete polynomial, then only we can do the solving, we can factorize it completely. So let's for the first step, we put in the suitable form for Qx. So our Qx here will be a linear, so ax plus b. So you can see when we expand here, we will go back to cubic polynomial. And our first information, they say the coefficient of this x cubed is 1. So when we expand here, it will be x times ax. So our ax cubed, the coefficient of this x cubed, which is 1. So here implies that our a will equals to 1. So therefore our polynomial here, we get our a equals to 1. And then p3 equals to 7. So second information, when we have p3 equals to 7, so I will substitute 3 into this polynomial, which is 3 minus 1, 3 minus 2, and then this linear where a already is 1, so it will be 3 plus b, then minus times 3 plus 5, it will equals to 7. So here we have 2 minus 1 equals to 7. So we find out what is our b. It will be plus 1, 8 divided by 2, 4. So b will be equals to 1. Therefore, our Qx part here, which is ax plus b, it is equals to 1x plus b. b also 1. A also 1, b also 1. So that will be our Qx. They said hence this part solve the x for px equals to 7 minus 3x. So we substitute our polynomial equals to 7 minus 3x. When you say solve, so find out what is your x value. That's the meaning. So we substitute our px here. Okay, substitute our px here with our qx together. Qx we already found, so we use it. So we solve it. When you want to solve it, it means we have to factorize. We have to expand and then we have to factorize and then find out what is our x. So when we expand this, expand 1 by 1, x minus 1, x plus 1. So I will get this x squared minus 1 times x minus 2. So I will take these two factors, expand first. It will be easier because x plus 1, x minus 1, it will be x squared minus 1. And then I move this value to the right hand side. I want to make it 0 so that we can factorize. So it become x minus 2 equals to 0 plus 3x, get x, minus 7, get negative 2. So we expand some more. What's our cubic here? X cubed. Okay, expand to the back, x cubed, and then negative 2x squared, and then negative x, and negative 2. So we can simplify. So we can simplify here, negative x plus x, this is 0, and then positive 2 is supposed to be positive 2. Here is positive 2. Positive 2 with negative 2 also can be simplified. So lastly, our cubic equation here, leaving x cubed minus 2x squared only. So we factorize it, x squared, x minus 2. So we can find our roots. X is 0, x is 2. So this will be our solving. Okay, so we look at, so for the first part, by applying our Qx is a linear concept here. This is our basic, because they said this polynomial is a cubic, so automatic here, the leading factor here should be a linear. So x times x, x times x, you will get x to the power of 3. Then we will manage to get A1 so far. So then we use the A1 that we know here to solve for B. So that will be answer AB. Then let our equation equals to the question given here, 7 minus 3x, and find out what is our x.